Hi, welcome to the Olympiad geometry. Let's continue our study. Today we're going to talk about the instant properties. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. Thank you. Let's see the first property. It seems that in center of a triangle is a concurrent point of three inner angle bisector lines. It's obvious, right? This is a definition of the incenter, and we can easily prove that three angle bisectors are concurrent. So let's say it's A, B, C, D, E. I draw the angle bisector line ADCE, and we know that they intersect on a point. Let's call it I. Right? We just need to prove that BI is also the angle bisector of angle ABC. So we can draw the projection point, let's call it PQR, right? Because we know that AI is the angle bisector of angle BAC, so we know that IP equals to IR. And because CI is the angle bisector of angle ACB, so IR equals to IQ. Which means that IP equals to IQ, right? IP equals to IQ, which means I is on the angle bisector of angle ABC. That means BI is the angle bisector, and we know that three angle bisector lines are concurrent. Okay, for property 2. Let I to be a point inside the triangle ABC. I is in center if and only if the distance of I to three edges are equal. So this is obvious because if I is in center, then we already know that the distance from I to three edges are equal. And if a point that makes if a point has the same distance from three edges, that means this point is on the angle bisector of three angles, which means that it is in center. So let's see property 3. Property 3. Let I be a point inside triangle ABC. Line AI intersects circumcircle of triangle ABC on D. I is in center if and only if ID equals to DB equals to DC. So let's draw a circle first. A, B, C. AI intersects the circumcircle on D. And we know that DB equals to DC equals to DI. So I is here. Right. Let's do the first thing that we already know I is in center. Right. So if I is in center. If I is in center, that means BI is the angle bisector of angle ABC. AI is the angle bisector of angle BAC, right? And I is in center, which means that this angle, the angle BAD, equals to angle DAC, which means arc BD or chord BD equals to arc DC and chord DC, which means BD equals to DC, right? So BD equals to DC. And let's see this angle, right? The angle BID equals to half of angle BAC plus half of angle ABC, right? And what about this angle? The angle IBD equals to half of angle ABC, which is this one, plus angle CBD. And because angle CBD equals to angle CAD, so that's half of angle BAC, right? And we can see that angle BID equals to angle IBD, which means IB equals to BD. And we already know that BD equals to DC, so IB equals to BD equals to DC. Right, that's the case. We know that I is a incenter. So let's see if BD equals to DC equals to DI. Right, BD equals to DC, which means the angle BAD equals to angle CAD, which means AI is the angle bisector of angle BAC, right? And BD equals to DI, which means BD equals to DI, which means angle BID equals to angle IBD, right? And angle BID equals to half of angle BAC, which we already know, right? Plus angle ABI. And angle IBD equals to half of angle, equals to angle IBC plus angle CBD. And we already know that BD equals to CD, these two are equal. So angle CBD equals to angle CAD equals to half of angle BAC, right? So that's BAC plus angle IBC, right? And we know that angle BID equals to angle IBD, which means angle ABI equals to angle IBC. So angle ABI equals to angle IBC. That means BI is the angle bisector of angle ABC, which means I is the incenter, right? Because that's the intersection point of two angle bisector lines. I is incenter. Okay, that's property 3. Let's see property 4. Property 4 saying that let I be a point inside triangle ABC. I is incenter if and only if angle BIC equals to 90 degree plus half of angle A, angle AIC equals to 90 degree plus half of angle B, angle AIB equals to 90 degree plus half of angle C. So let's do it. Let's do it this way. Just draw the okay. This is I. Let's see. We already know that I is an incenter. Okay. So if I is incenter, which means angle BIC plus half of angle ABC plus half of angle ACB, right? BIC plus half of angle ABC, that's this angle, plus half of angle ACB, that's this angle, equals to 180 degree. And we already know that twice of half of angle ABC plus half of angle BAC plus half of angle ACB equals to 180 degree, right? Which means 90 degree plus half of angle ABC plus half of angle BAC plus half of angle ACB equals to 180 degree. Right? So angle BIC plus half of angle ABC plus half of angle ACB equals to 90 degree plus half of angle ABC plus half of angle BAC plus half of angle ACB. Right, that is straightforward. So we cancel the half of angle ABC and half of angle ACB out. Right, so we know that angle BIC equals to 90 degree plus half of angle BAC, which is angle A, right? And similarly, we can prove that angle AIC equals to 90 degree plus half of angle B, angle AIB equals to half of 90 degree plus half of angle C, right? And now let's see. We have another point. Let's call it I prime. Okay, I prime is different to point I. But I prime satisfies the condition that angle BI prime C equals to 90 degree plus half of angle A, and angle AI prime C equals to 90 degree plus half of angle B. Angle CI BI prime A equals to 90 degree plus half of angle C. Right? How can we prove that I prime is I? That's a question. So we already know that point I prime satisfies these conditions, and we already know that for the incenter I satisfies the condition that angle BIC equals to 90 degree plus half of angle A, and angle AIC equals to 90 degree plus half of angle B, and angle BIA equals to 90 degree plus half of angle C, right? Which means from the first one, we know that BI prime IC are cyclic. And from second one, we know that AI prime IC are cyclic. From the third one, we know that BI prime IA are cyclic. Right, which means BC is let's call this one circle O1, this one circle O2, this one circle O3, right? Which means, so we have BC, let me draw it like this. It would be easier to. Right. Okay. So that means if we look at these two, right? Circle O1 and circle O2. Circle O1 and circle O2 has 3 common points. That's impossible, right? Which means I prime is I, right? The assumption is incorrect that I prime is a different point than I is incorrect, right? Because we got 2 circles, they have 3 different intersection points. That's impossible. Okay. So let's see the property 5. Property 5 is saying that let I be a point inside triangle ABC. I is in center if and only if the circumcenter of triangle IBC, triangle ICA, triangle IAB are on the circumcircle of triangle ABC. So let's draw it here. We first draw the circumcircle of triangle ABC. And let's this should be the midpoint. Okay, this is I. If I is a incenter, then we know that point D would be the circumcenter of triangle BIC, right? Because BD equals to BC equals to DI. BD equals to DC equals to DI, right? Similar for the point E and F. They are the circumcenter of triangle AIC and triangle AIB respectively. So the next case would be that if triangle AIB, so if the circumcenter of triangle AIB, triangle AIC, and triangle BIC are on circumcircle of triangle ABC, right? Okay, let's just think about the triangle BIC for now. We know that triangle BIC has a circumcircle, right? That means the center of this circumcircle has the same distance to point B and point C, which means this point, the center, which means the center of, because we already know it's on the circumcircle of triangle ABC, right? And we also know that the center of the circumcircle of triangle BIC has same distance to B and C, right? Which means this center is a midpoint. The center is a midpoint of triangle, midpoint of arc BC, right? That's a midpoint. And we know the center of the triangle AIB would be the midpoint of arc AB, right? Similarly, to the triangle AIB, the center would be midpoint of arc AB, right? And similarly, the center of the center of the circumcircle of triangle AIC would be the midpoint of arc AC, right? So now it looks like what? It looks like this. We have a triangle, and we find the midpoint. Right, we find the midpoint here, midpoint here, midpoint here. That is the center of the triangle, circumcircle of triangle IBC, right? Let's call it I prime, for instance. So I draw it like it's a different point than the incenter, right? So we are trying to prove that this point is incenter. So let's just draw it as a different point, so it will be easier for us to understand. We know the distance from this one. Okay. So now if I look at, here is I prime. Okay. If I look at the triangle BI prime C, and we know there is a circumcircle for it, right? And for the triangle BI prime A, we have another circumcircle. Okay. So we already know that the midpoint, and so this is a midpoint, let's call it D, let's call it E. We already know that the point I is also on this circle, right? Because dB equals to dC equals to di as well. So I is on circle D. And similarly, I is also on circle E. But circle D and circle E has two intersection point. As B and I prime, which means it's possible that I is on both circle D and circle E, right? Which means the assumption that I prime is a different point than I is false. So I prime is on I. Okay. I think we introduced this method before, right? Hopefully you still remember that. Let's see the property 6. Property 6 is saying that a line intersects the triangle and split the perimeter and area of triangle into two sections, L1, L2, and S1, S2, respectively. The line is passing through the incenter if and only if L1 to L2 equals to S1 to S2. So let's draw a this is point I. Okay, so A, B, C, P, Q. Right, the line L splits the triangle ABC into two parts: the triangle APQ and the quadrilateral BCQP. Right, and the parameter separation would be AP plus AQ equals to L1, BP plus BC plus CQ equals to L2. And we basically want to prove that if and only if PQ passing through Incenter, then L1 to L2 equals to the area of triangle APQ to the area of BCQP, right? Let's say that if the L is passing through the incenter, right, then we can find the projection point from I to the three edges, right? Let's call it D, E, F. We know that ID equals to IE equals to IF, right? So the area of triangle APQ would be AP times IF, half of AP times IF, right? So half of R times AP. That's a triangle API actually here. And the area of triangle AQI equals to half of AQ times R, which means triangle area APQ can be calculated as half R times AP plus AQ equals to half R times L1, right? And the area of BCQP equals to 3 parts, right? So equals to the area of triangle BPI plus area of triangle BIC plus area of triangle CQI. So that equals to half of PB plus half of PB times R plus half of BC times R plus half of CQ times R. So equals to half R times PB plus BC plus CQ equals to half of R times L2, right? Which means this area ratio APQ to BCQP equals to half of R times L1 divided by half R times L2. That's L1 to L2, right? We just proved that. So we want to prove that if APQ area to BPCQ equals to L1 to L2, right? We want to prove that it's passing through the circumcenter, right? So let's do this. First, we draw a line here, which is the angle bisector of angle BAC. We call this point as I prime, okay? And we connect BI prime and connect CI prime, okay? We do projection from I prime to AB, AC, and BC. It's D, E, F. right? We already know that AI prime. So I prime is the intersection point of the angle bisector of angle BAC to the line L, right? So we know that I prime E equals to I prime F, right? And the triangle area APQ can be calculated as AP plus AQ times I prime F times half of it, right? And what about the triangle B? Not triangle, the area of BPQC. It equals to half of BP plus CQ times I prime F and plus I prime D times BC. Half of it. Right. I hope you are following this. Which means that we can find the ratio of APQ to BPQC that equals to half of I prime F AP plus AQ to half of BP plus CQ times I prime F plus half of I prime D times BC, right? It equals to AP plus AQ to BP plus CQ plus I prime D to I prime F times BC. And we know this one equals to L1 to L2. What is L1? It's this one, L2 is this one. So L1 to L2 is AP plus AQ to BP plus CQ plus BC, which means I prime D to I prime F equals to 1, right? When I prime D to I prime F equals to 1 means that I prime E equals to I prime F equals to I prime D, which means I prime is a point that has the same distance to 3 edges, which means I prime is the incenter. Okay. Let's see the next one. The property 7 is saying that let I be the incenter of triangle ABC. BC equals to A, AB equals to B, AB equals to C, AC equals to B. The projection of I on BC, AC, AB are D, F respectively. Radius of incenter is R, P is half of A plus B plus C. Then ID equals to IE equals to RF equals to R. This is obvious. We don't need to prove that. The triangle area is P times R. This is also obvious. And R equals to this one. This comes from this one. That's obviously true. And we want to calculate for AE and AF. So let's see. I is the incenter. This is D. This is E. This is F. right? We know that AB, AC, BC are the tangent lines for the circle I, right? So AF equals to AE, and BD equals to BF, CD equals to CE, right? So this side is C, this side is B, this side is A. So we know that AF plus BF equals to C. And this one would be AF plus CE equals to B. So here would be BF plus CE equals to A. So we can solve this, right? We can solve this. So BF equals to A minus CE, right? We replace the BF into this one. So we got AF plus A minus CE equals to C, and AF plus CE equals to B, which means 2AF equals to B plus C minus A, which means AF is half of B plus C minus A equals to half of A plus B plus C minus A equals to P minus A, right? Similarly, we can get BF equals to P minus B and CE equals to P minus C. So we just approve the second one. And let's see the third one. ABC times R equals to P times AI times BI times CI. Right, we want to prove that ABC times R equals to P times AI times BI times CI. The first thing we need to notice is that we're looking for the relationship between ABC and AI, BI, CI, right? Here is R, and this is AI. So we know that R to AI equals to sine half of angle A, right? And R to BI equals to sine half of angle B. R to CI equals to sine half of angle C. Also, we already know AF equals to P minus A, so P minus A to AI equals to cosine half of angle A. P minus B to BI equals to cosine half of angle B. P minus C to CI equals to cosine half of angle C. Right? So let's multiply them together. We got R to the power 3 times P minus A, P minus B, P minus C to AI squared, BI squared, CI squared equals to sine half of angle A cosine half of angle A, sine half of angle B cosine half of angle B, sine plus sine half of angle C cosine half of angle C. Right? So we can, it equals to half of, oh, this is time, right? This is not plus, this is time. So it equals to 1/8 times 2 of this, and 2 times this, 2 times this, 2 times this. That's sine angle A times sine angle B times sine angle C, right? So we got this equation. And what is sine angle A? Sine angle A equals to, sine angle A is, if you remember the circumcenter, the sine angle A, we have half of A2R, that's sine angle A, right? So here, A22R, right? So we can rewrite this as 128 times A22R times B22R, that's sine angle B, times C22R, that's sine angle C, which means we get this 2R times R, 2R times R here, 2R times another R here, and here is ABC, right? So we got 8 times 2R to the power 3 times P minus A, P minus B, P minus C, 2 AI squared, BI squared, CI squared equals to ABC. Right. So remember that 2RR, what is that? We actually calculated this before, right? Because let me just recalculate it. Half of, look at this triangle, half of AB sine C equals 2. The area of triangle ABC equals 2. Half of A plus B plus C times R, right? And this one, the sine C equals 2 C by 2R, right? So how ABC by 4R equals 2 half of A plus B plus C times R, which means ABC to A plus B plus C equals to 2RR, right? So we replace this 2RR by this one. We got 8 times ABC to A plus B plus C to the power 3 times P minus A, P minus B, P minus C divided by AI squared, BI squared, CI squared equals to ABC. Right? So now we have, let's write it here. So we have 8 times A squared, B squared, C squared times 1 by A plus B plus C to the power 4, right? See here, 4, and times A plus B plus C, and times P minus A, P minus B, P minus C, right? I have this out, divided by AI squared, BI squared, CI squared equals to 1. Right, I cancel one of the ABC out and then extract A plus B plus C to here and get this one. So this one is 2P, right? So we get 16 times A squared, B squared, C squared divided by A plus B plus C to the power 4 times AI squared times BI squared times CI squared times, this is P, right? So P minus A, P minus B, P minus C equals to 1, right? And we know this one is area square, right? So we got 4ABC times area, ABC 2, A plus B plus C squared times AI times BI times CI equals to 1, right? And what is a triangle ABC? That is a half of R times A plus B plus C, right? So we get ABC times 4 times this one, that is half of PR equals to A plus B plus C squared times AI times BI times CI, right? So this one equals to 4P squared times AI times BI times CI. This is not half, right? PR, that's half already here. That's P, so PR. So we have 4 cancel out and P cancel one of them. So we got ABC times R equals to A plus of P times AI times BI times CI, right? Which is the one that we are looking for. Okay, so that's property 7. Let's check property 8. Property 8 is saying that let I be the incenter of triangle ABC. So let's just draw the I be the incenter of triangle ABC. Right, and BC equals to A, AC equals to B, AB equals to C. Angle bisector of angle A meet BC on K. So this is K, this is I. And meet circumcircle of triangle ABC on D. So this is D. Then we want to find the ratio of AI to KI, AD to DI, and DI to DK. We want to prove it equals to B plus C to A, right? So the first thing is that AI to KI, right? AI to KI, because BI is an angle bisector, so AI to KI equals to AB to BK, right? It equals 2. So this is C, and we already know that AK is the angle bisector of angle BAC. So BK to KC equals 2, AB to AC equals 2, C to B, right? So we know that BK, the length of BK equals to AC to B plus C, and the length of KC equals to AB to B plus C, right? So AB to BK equals to AB is C divided by BK is AC to B plus C equals to B plus C to A, right? And we want to find AD to DI. Okay, let's see this one. So because this angle equals to this angle equals to this angle, right? So angle DBK, equals to angle BAD. And angle BDK equals to angle BDA, which means triangle BDK is similar to triangle ADB, which means BD to DK equals to BD to DK equals to AD to DB. BDK. This angle equals to this angle, right? B is from this point. Yeah, BDK. So AD to DB. Equals to AD to DI, right? So BD to DK and BD equals to DI equals to DI to DK. So firstly, we just prove that AD to DI equals to DI to DK, right? AD to DI equals to DI to DK by proving these two triangles are similar, right? So now let's see how to find the real ratio of it. So we want to calculate the based on AD to DI. Can we calculate the AD out? I don't think so, right? Because, yeah, we cannot, it's difficult to directly calculate the AD and then calculate the DI, right? But the DI, see here, AD to DI equals to DI to DK. So we can use this one, the DI, which is BD to DK, right? BD to DK equals to sine of this angle, BDK to sine angle, see, BD to DK is sine angle BKD, sorry, so the sine angle BKD to sine angle KBD, right? In triangle BKD, that BD to DK is sine angle equals to the ratio of sine angle BKD to sine angle KBD, right? And because angle BKD equals to angle AKC, so that's sine angle AKC to sine angle KBD is a angle DAC, right, equals to sine angle DAC. So, and in the triangle AKC, the sine angle KAC to sine angle AKC to sine angle DAC, which is sine angle AKC, equals to AKC, that's AC, to KC, right? So it equals to, which is AC is B, right? And the KC is this one, AB to B plus C. So it equals to B plus C to A. And we already proved that BK to DK equals to DI to DK equals to AD to DI. So all of them equals to B plus C to A. Okay, that's property 8. And let's see the property 9. Okay, property 9 here. Property 9 is saying that any line passing through I, the incenter of triangle ABC, meets ABAC on PQ, respectively. Then these two equations are valid. So let's just use this one. It's saying that we have the incenter here, and we have a line passing through it. Make it A, B, C, I, P, Q. We want to prove that AB to AP times AC plus AC to AQ times AB equals to AB plus AC plus BC. Right. So basically we want to prove that ABAC to ABAC times 1 to AP plus 1 to AQ equals to AB plus AC plus BC. Right. And remember that, just look at this equation, right? AB times AC just remind us the area of triangle ABC, and AB plus AC plus BC also remind us how we can calculate the area of the triangle ABC, right? So we can do this. We times the half of R to left and the right of the equation, AB times AC times AQ plus AP to AP times AQ. We want to prove half of R times AB plus AC plus BC. We want to basically prove this, right? And we know the right side is the area of triangle ABC. So we just need to find out what says, right? If it equals to the area of triangle ABC, then the proof is done. So AB times AC divided by AP times AQ times AP plus AQ times half of R, right? So that's the area of triangle APQ, right? AP plus AQ times R times 0.5. So it equals to AB times AC to AP times AQ times area of triangle APQ. And we know the triangle APQ can be written as half of AP times AQ times the sine angle BAC, right? So it equals to AB times AC times the half of sine angle BAC, which is the area of triangle ABC, right? So these two are equal. Okay, so this is valid. We just proved that. And for the next one, that equals to sine B, sine C, sine A, sine B, sine C plus them together. So we already know that AC to sine B equals to AB to sine C equals to BC to sine A. So this is true, right? Based on the sine theorem. So let's see the last property. Let I be the incenter of the triangle ABC. P is any point inside of any point in the triangle ABC. Projection of P to BC, CA, AB are DEF. So we have A, B, C here, and we have a point P here. We have PD, PE, PF. We want to prove that BC to PD, BC to PD, plus CA to PE, CA to PE, plus AB to PF, AB to PF is minimum 1P overlaps I, right? 1P is I, then it has a minimum value. So I'm not sure the audience understand a little bit of the Cauchy inequality or not, but hopefully you know that. Then this would be a straightforward thing, because let's set BC equals to A, AC equals to B, AB equals to C, and let's set the PD to be X, PE to be Y, PC to be Z. So we're looking for X to A plus Y to B plus C to Z, right? And we know that AX, half of AX plus half of BY plus half of CZ is the area of triangle ABC, which means it's a constant, right? The summation is a constant. So if we use this one times AX plus BY plus CZ, right? Based on the Cauchy inequality, we know that I think I need to introduce a Cauchy inequality for a second. Let me just do that again. I did something wrong here, right? This is wrong. This is C to Z. Sorry, this is wrong. So it should be A to X plus B to Y plus C to Z, right? Times AX plus BY plus CZ, right? This is always larger than these two and squat. So squat A to X times AX plus squat B to Y times BY plus squat C to Z times CZ square, which is A plus B plus C square, right? It's always larger than this one, so that's a minimum. And it is true only if A to X to AX equals to B to Y to BY equals to C to Z to CZ, right? Which means X equals to Y equals to Z. And under that condition, we know that P is I. P is point I. Right. So that's a little bit of algebra, but it is what it is. So let's just do a short review. In this video, we introduce the properties of the incenter, right? If I want to mark, I would say this one, property 4, property 3, okay, property 3, property 4, and property 8. These three are the most critical ones. Okay, these three are the most critical ones. I repeated it. These three are the most critical ones that you need to know about and remember about, because they are so widely used in solving the problems that associated with the incenters. Others are not that common to use, so we will see how we do the application on these three properties in the problems. Okay, I hope you like this video. See you in next one. Thank you.